Welcome to Creata classes. In this lecture also we will cover the questions related to area and the perimeters. So let's begin with the questions. Let's take the first question. The question is, what is the area of the dark colored sector for the figure given below? 4 choices are given. Our first step, we will observe the question. In this figure, a circle is given of the radius 4 cm. The radius of this circle is 4 cm. And the dark colored sector whose area we have to calculate, the angle with the center is given as 120 degree. So basically this is a sector. So in this question we have to calculate the area of the sector. And we have done the formula of area of the sector, which is equal to theta upon 360 into pi r square. We can apply this formula to solve for the answer. Otherwise, we can also use the unitary method. That is, we know the area of the complete circle is equal to pi r square. Okay, we know the basic formula of the area of the circle. Or we can say area of the sector with the angle as 360 degree is equal to pi r square. For 360 degree, the area is pi r square. And for the angle 120 degree, the area will be 120 degree upon 360 degree into pi r square. Okay, we have applied the simple unitary method. So let's put the value, that is radius as 4 cm. On putting the value and also putting the value of pi as 22/7 and solving, we got the answer as 16.76. So this is the answer of the question. So the fundamental that we have used to solve this question is the basic formula of the area of the sector, which is equal to theta upon 360 into pi r square. And we have also seen the different approach, that is we have used a unitary method, in which we have seen that area of the complete circle is the area of the sector with 360 degree angle. So applying the unitary method, we have calculated for 120 degree, the area will be 120 upon 360 into pi r square. So we have applied the basic fundamental to solve this question. So let's move to the next question. The question is, O is the center of the circle and angle AOB is 150 degree and the shaded portion is X part of the circular region. Then X is, 4 choices are given. So let's approach the question. Our first step, we will observe and visualize the question. So let's observe this figure. This question is saying the angle AOB in the given figure is 150 degree. This angle is given as 150 degree. By looking at the figure, we can say both of these angles are vertically opposite angle, means both of these angles will be equal to each other. So this is observation. Moving further to the question, it is talking about this shaded region. And in the question, it is given as the shaded portion is X part of the circular region. Okay, and we have to calculate the value of X, that is this shaded region is how much part of the complete circle. So let's approach the question. So basically we have to calculate area of this complete circle and area of this shaded region, and we have to tell how much part is the area of this shaded region of the complete circle. So let's see. So first of all, we will calculate the area of this circle. So let's assume the radius of the circle as r. So we can say the area of the circle will be pi r square. We got the area of the circle. Moving further, these shaded region are basically the sector of this circle. So first of all, we will calculate the angle this sector is making at the center. Let's assume this angle is x, then this angle will also be equal to x. Why? Because both are vertically opposite angle. These two angles we know as 150 degree and 150 degree, and we know the complete revolution of a circle is 360 degree. So we got the value of angle x as 30 degree. Okay, we got value of angle x as 30 degree. And we know area of the sector is theta upon 360 into pi r square. Here theta is 30 degree. So we got area of this one sector as 1 upon 12 pi r square. Similarly, we can calculate area of this sector also as pi r square upon 12. Let's add area of both of this sector. We got area of both of this sector as 1/6 pi r square. and pi r square is the area of this complete circle. So we got area of this sector is 1 by 6 of the area of the complete sector. That is the answer of the question, that is 1 by 6. Okay, so the fundamental that we have used to solve this question is the area of the sector, which is equal to theta by 360 into pi r square. So based on this basic fundamental, we have solved this question. So let's move to the next question. The question is, the area of the shaded region in the figure given below is, 4 choices are given. Our first step, we will observe and visualize this question. So first of all, let's refer this figure. A circle has been given and the radius of the circle is given as a unit. This dimension is a, means radius of this circle is a. A triangle is formed inside this circle and we have to calculate area of this shaded region. So let's proceed with the question. A is the radius of the circle, so can we calculate the area of the circle as pi r square? Here radius is a, so we got area of the circle as pi a square. Further, this portion is the semicircle, that is half of the circle. So can we say area of the semicircle will be equal to half of the area of the circle, which will be equal to half into pi a square. Okay, so we got the area of this semicircle as half pi a square. Moving further, are you able to observe this triangle inside this circle? Can we calculate the area of this triangle? Let's try so. Here for this triangle, this height is given as a and base of this triangle is the twice of the radius. Means this dimension is a and this dimension is a, so we can say the base of this triangle will be a plus a, that is 2a. So we can calculate the area of this triangle as half into base into height. That will comes out to be a square. We got the area of this triangle as a square. Now we can simply calculate area of the shaded region as area of this semicircle minus area of this triangle. By subtracting area of this triangle from this semicircle, we will get the area of this shaded region. So let's put the value. We got our answer, that is area of the shaded region as a square times pi by 2 minus 1. That is the answer of the question. Okay, got it? So let's move to the next question. The question is, 3 coins of the same size, radius 1 cm, are placed on a table such that each of them touches the other two. The area enclosed by the coins is, 4 choices are given. Okay, our first step, we will observe and visualize this question. This question is talking about 3 coins of radius 1 cm which are placed on a table such that each of them touches each other. These are the 3 coins. These 3 coins are touching each other and radius of these 3 coins are given as 1 cm. And in this question we have to calculate the enclosed area, that is this shaded area. Got it? So let's approach the question. Here the radius of these 3 coins are given as 1 cm. Let's join the center of all these 3 circles. Are you able to observe on joining the center of these 3 circles or the 3 coins, a triangle is formed? And in the question, the radius of this coin or this circle is given as 1 cm. So can we say this dimension will equal to 1 cm plus 1 cm, that is 2 cm? Similarly, the length of this side of the triangle will also be equal to 1 cm plus 1 cm, that is 2 cm. Similarly, the third side of the triangle is also equal to 2 cm. So we got all the 3 sides of this triangle is equal to 2 cm. That is, this triangle is a equilateral triangle. All the 3 sides of an equilateral triangle are equal. So we got this triangle as an equilateral triangle. And we know the property of the equilateral triangle, that is all the 3 angles of the equilateral triangle are equal, that is equal to 60 degree. So we got all these 3 angles as 60 degree. Moving further, in this question we have to calculate area of this shaded region. If somehow we are able to find area of this complete triangle and area of these 3 sectors, okay, these 3 are the sector of the circle. If somehow we are able to find the area of these three sectors and we subtract it from the area of this complete triangle, can we get area of our shaded region? Okay, that is the enclosed area. Okay, this approach we will use to solve this question. We will find area of this triangle. Further, we will find area of this sector and we will subtract area of these three sectors from the area of the triangle to get the area of the shaded region. Let's do so. First of all, we will try to find the area of this triangle. This is an equilateral triangle and we know area of an equilateral triangle is equal to a square root 3 upon 4. Here A is the side of this triangle which is 2 centimeter. Okay, let's put the value. So we got area of this triangle as root 3 centimeter square. Let's move further. Let's try to find the area of this sector. And we know area of the sector is equal to theta by 360 into pi r square. Here theta we have calculated as 60 degree and radius of the circle is given as 1 centimeter. So on putting the value and solving, we got area of this sector as pi by 6 centimeter square. And area of all these three sectors will be equal to each other. Why? Because all these three sectors are making angle of 60 degree at the center. So area of all these three sectors will be equal to pi by 6. Let's add area of all these three sectors. We got the area of these three sectors as pi by 6 into 3, which is equal to pi by 2. Okay, got it. Let's move further. We have got area of these three sectors and area of this triangle. Let's find the area of this shaded region, which will be equal to area of the triangle minus area of three sectors. Let's put the value and solve it. We got our answer as root 3 minus pi by 2 centimeter square. Okay, that is the answer of the question. So the fundamental that we have used to solve this question is we have to find the area of this shaded region, which will be equal to area of this complete triangle minus area of these three sectors. And we have calculated area of this equilateral triangle with the help of the formula, that is a square root 3 by 4, and area of the sector as theta by 360 into pi r square. So based on these basic fundamentals, we have solved this question. Got it? Let's move to the next question. The question is the area of the regular hexagon with side A is, 4 choices are given. So let's approach this question. The question is talking about a regular hexagon. And we know regular hexagon is a hexagon which is having all the sides as equal. That is an equilateral hexagon. All the angles and all the sides of a regular hexagon are equal to each other. And in this question, we have to find the area of this regular hexagon. This is one of the important questions. Based on this question, several questions can be asked. So you should know the area of a regular hexagon that we are just going to calculate. This is a regular hexagon. Let's have the sides of this regular hexagon as A unit. All of the sides are equal to A. And we know a regular hexagon is composed of 6 equilateral triangles. These are the 6 equilateral triangles this regular hexagon is composed of. These are the 6 equilateral triangles. And we know the side of this equilateral triangle as A. And we also know the formula of the area of the equilateral triangle, which is equal to root 3 by 4 A square. We got area of one of the equilateral triangle. Let's find the area of this complete hexagon, which is equal to addition of area of all of the 6 equilateral triangles. So we got area of this regular hexagon is equal to 6 into area of this equilateral triangle. So on putting the value and solving, we got our answer as 9 by 2 root 3 A square. That is the area of an regular hexagon and also the answer to this question. This question is basically a basic fundamental which can be used and applied in other questions related to area of an regular hexagon. You should know that a regular hexagon is composed of 6 equilateral triangles. Okay, it is having 6 sides. So 6 triangles can be formed inside this hexagon. And we know the formula of area of equilateral triangle, which is equal to root 3 by 4 A square. So by applying simple mathematics, we can solve for the area of this regular hexagon. Okay, got it? So based on the same fundamental, we will take one more question. The question is, in a given figure, ABCDEF is a regular hexagon whose side is 6 cm. APF, QAB, DCR and DES are the equilateral triangles. What is the area of the shaded region? Four choices are given. So our first step, we will observe and visualize this question. Let's refer this figure. First of all, in this figure, ABCDEF is given as a regular hexagon. So firstly, let's segregate this regular hexagon out of the figure. This is a regular hexagon and we know all the 6 sides of a regular hexagon are equal to each other. It means all these 6 sides will be equal to 6 cm that is given in this question. Further, we also know the regular hexagon is composed of 6 equilateral triangles. So let's join A to D. Okay, on joining the point A to D, we got 6 equilateral triangles inside this regular hexagon. These are the 6 equilateral triangles. Let's come back to our figure. Here, addition to this regular hexagon, 4 triangles are given which are also equilateral triangles. And sides of this equilateral triangle are given as 6 cm. So basically, this complete figure is composed of many equilateral triangles. And sides of this equilateral triangle are given in this question, that is 6 cm. And in this question, we have to calculate the area of the shaded region. If you observe, this shaded region is composed of total 8 equilateral triangles. Okay, these are the 8 equilateral triangles inside this shaded region. So basically, we have to calculate area of these 8 equilateral triangles. And we know the formula of area of equilateral triangle is equal to root 3 by 4 a square. Here a, that is side of this triangle, is given as 6 cm. So let's put the value. We got area of a single equilateral triangle as 9 root 3 cm square. We got the area of one equilateral triangle. So let's calculate the area of the shaded region, that is 8 equilateral triangle as 8 into 9 root 3. We got the answer as 72 root 3 cm square. That is the answer of the question. So the fundamental that we have used to solve this question is that a regular hexagon is composed of 6 equilateral triangles. And we have calculated the number of equilateral triangles in the given figure. We got total 8 equilateral triangles and all these equilateral triangles are having the side as 6 cm. And we know the formula of area of equilateral triangle as a square root 3 by 4. On putting the value, we got our answer. Okay, that is the approach we have used. Okay, let's move to the next question. The question is, if area of an equilateral triangle is A and height B, then the value of B square upon A is, 4 choices are given. Okay, our first step, we will observe and visualize this question. This question is talking about a equilateral triangle. And area of this triangle is given as A and height of this triangle as given as B. And we have to calculate the ratio of B square upon A, that is height square upon area. Let's proceed with this question. So first of all, we will assume the side of this triangle as x. All the 3 sides will be equal to x as it is a equilateral triangle. And we know the formula of area of equilateral triangle. What it is? It is a square root 3 upon 4. Here A is the side of the equilateral triangle that we have assumed as x. So let's put the value. We got area of this triangle as x square root 3 by 4. Moving further, here AD is given as height of this triangle, which is equal to B. Here ABC is an equilateral triangle, that is AD is dividing this equilateral triangle into 2 equal parts. That is both of these triangles are congruent triangle. Okay, we are not going into the detail of congruency. Both of these triangles will be congruent to each other. So basically AD, that is height of this triangle, is dividing the triangle ABC into 2 equal triangles. So we can say BD is equal to DC, that is D is the midpoint of BC, and angle D is equal to 90 degree, that is both of this angle will be equal to 90 degree. The height AD of an equilateral triangle is dividing this triangle into 2 equal halves. Okay, by the help of congruency we can prove the same, but we are not going into the detail of the same. Moving further, we got angle D as a 90-degree angle. That is, the triangle ADC is a right angle triangle. If this is a right angle triangle, can we apply the Pythagoras? Let's apply the Pythagoras. AD it is given as B, AC we have assumed as X, and DC is the half of side BC, so DC will be equal to X by 2. Okay, the side BC is X, so DC will be equal to X by 2. Let's apply the Pythagoras. On applying the Pythagoras, we got height of this triangle as root 3 x by 2. We got height of this triangle. And we have already calculated the area of this triangle as root 3 by 4 x square. We got the value of A and we got the value of B. And in the question, we have to calculate the value of B square upon A. Let's put the value and let's solve it. On solving, we got the answer as root 3. Root 3 is the answer to this question. So the fundamental that we have used to solve this question is, we have applied the formula of area of the equilateral triangle, that is equal to root 3 by 4 a square. Further, we have seen that the height of the equilateral triangle divide the equilateral triangle into two equal parts. That is, AD has divided the triangle into two equal parts. We got D as the midpoint of side BC and we got angle D as equal to 90 degree. So based on these basic fundamentals, we have solved this question. Okay. Let's move to next question. The question is, in a given figure, AB, AE, EF, FG and GB are semicircles. AB is equal to 56 cm and AE is equal to EF is equal to FG is equal to GB. What is the area of the shaded region? Our first step, we will observe and visualize this question. In this question, a figure is given. Okay, let's refer the figure. In this figure, AB is given as semicircle and also AE, EF, FG and GB are also given as semicircles. Further, AB, that is this complete length, is given as 56 cm and further AE, EF, FG and GB are given as equal to each other. Here AB is 56 cm and it is divided into 4 equal parts. So we got each part as 56 by 4, that is 14 cm. We got length of all this line segment as 14 cm. Basically AB is the semicircle and AB is given as 56 cm, that is diameter of the semicircle is 56 cm. Or we can say radius, that is half of the diameter, will be equal to 28 cm. Similarly, diameter of these 4 circles we have calculated as 14 cm. That is, radius of these 4 circles will be equal to half of the diameter, that is 14 by 2, that is 7 cm. We got radius of all these 4 semicircles as 7 cm and radius of this big semicircle as 28 cm. And in this question, we have to calculate area of this shaded region. That is, we have to calculate area of this circle. So first of all, let's assume the center point of this circle as point O and this topmost point of this circle as point C and the bottommost point of this circle as point D. Let's join point C to F. Okay, we got a line segment CF. Further, let's assume radius of this shaded circle as R. Okay, we got CO is equal to R and also OD is equal to R. CO and OD are the radius of this circle. We have assumed radius of this circle as capital R. Moving further, we got CD, that is the diameter of the circle, as twice of R. Further, let's also assume FD, that is this line segment, as X. So this complete length, that is CF, will be equal to twice of R plus X. And CF is also the radius of the semicircle. And we have calculated radius of the semicircle as 28 cm. Okay, got it. Radius of the semicircle is 28 cm, that is CF is equal to 28 cm. So we got 2R plus X is equal to 28 cm. Moving further, let's join point A to point C. We got the line segment AC. Moving further, let's assume center point of the semicircle EF as point H. H is the center of the semicircle EF. Let's join point O to point H. We got the line segment OH. Are you able to observe? We got a right angle triangle OHF. Okay, this is a right angle triangle. So can we apply the Pythagoras in this triangle? We got OH square is equal to HF square plus OF square. Here OH will be equal to radius of the semicircle plus radius of this circle. That will be equal to 7 plus R. Okay, radius of the semicircle is 7 and radius of this circle we have assumed as capital R. So we got the length of OH is equal to 7 plus R. Further, HF is the radius of this semicircle which will be equal to 7 cm. And OF will be equal to R plus X. OD is R and DF is X, so we got OF is equal to R plus X. Let's put the value and let's solve it. We got 7 plus R whole square minus R plus X whole square is equal to 49. Here this expression is resembling A square minus B square, which is equal to A plus B into A minus B. Let's solve it mathematically. On solving, we got value of 7 minus X is equal to 7 by 5. That is, we got X is equal to 28 by 5, that is 5.6 centimeters. We got the value of X, that is, we got the value of DF. Further, we know 2R plus X is equal to 28 centimeter and we have calculated the value of X. Let's put the value of X. On solving, we got R, that is radius of the circle, as 11.2 centimeter. Once we got the radius of the circle, we can calculate the area of the circle as pi r square. Let's put the value. We got area of the circle as 394.24 centimeter square. That is the answer of the question. So let's see the approach that we have used to solve this question. In this question, many semicircles are given. So firstly, we have calculated radius of all these semicircles. Further, we have assumed radius of this shaded circle as capital R and DF as X. Further, we have identified a right angle triangle, that is triangle OHF. So by applying the Pythagoras and simple mathematics, we got the radius of our shaded circle. Once we got the radius of this shaded circle, we have applied the formula of area of the circle, that is pi r square, to got the answer of this question. So this is the approach to solve this question. Okay students, we have done with the questions on area and perimeter. Hope you have enjoyed the session. We have tried to cover the wide range of questions. Okay. So that's it for this lecture. Thank you very much for being with Creata classes. Bye for now.